Good morning, all my dear students of third prep. Mrs. Yam Said speaks from Egyptian Language School in Doha, Qatar. And today we study a new lesson in the science curriculum for the second term, Unit 2, Lesson 1, which is the physical properties of the electric current. My dear students, we start our lesson with the uses or the importance of the electric current in our daily life. If I ask you, what is the importance of the electricity in our life? You can say we use it to operate our home devices like the washing machine, the fridge, or even televisions, computers, and many other home devices. We can also use it to light our homes, to light hospitals, shopping malls, and many other places. So, the uses of electricity in our life, as I said, to light up our homes, factories, to operate our home machines like heaters, televisions, washing machine, and many other devices, etc. And now, my dear students, I just want to say that the electricity is referred to many other forms of energy because it is considered as the cleanest form of energy. As a cleanest form of energy, it doesn't cause any pollution. So, let me show you that part of the electric power station. We call this part as a substation. When I say substation, I mean the part of the electric power station which is used to transmit or to carry or to deliver the electric current to our homes. My dear students, let me remind you of the structure of the atom. This is called the nucleus of the atom. The nucleus of the atom locates at the central part of the atom. At the central part of the atom, we have the nucleus, and most of the atomic mass is concentrated in the nucleus of the atom. It locates in the central part of the atom, containing positively charged protons and uncharged neutrons. The neutrons are uncharged or neutral particles. So, let's count the number of positive protons here, I mean in this atom. It contains 1, 2, and 3. So it has 3 positive protons. And let's count the number of the uncharged neutrons. Their number is 1. Here's 1 neutron, 2, 3, and 4. So we have 4 neutrons. At the same time, the number of the negative electrons which revolve around the nucleus of the atoms, we have 1. Let's count the number of negative electrons. They are 1, 2, 3. So the nucleus of this atom contains 3 negative electrons, 3 negative electrons, 3 positive protons. So the number of positive protons is equal to the number of negative electrons. 3 positive protons inside the nucleus. 3 negative electrons revolve around the nucleus. Let's count their number again. 1 electron, 2, and 3 electrons. They are equal in their number. I mean, electrons and protons are equal in their number, different or opposite in their charges. So between the electrons, between the electrons and the protons, there is an attraction force. The force here is called the attraction force or the force of attraction. And this attraction force may be weak force or strong force. Let's focus on this atom. This atom is considered as a metal element. Why? Because it has number of electrons in the outermost energy level. How many electrons in this atom? I mean in the outer level. في آخر level هنا عندي كام atom يا حلوين؟ عندي 3 sorry. In the outermost level, we have only one electron. Here, we have only one electron in the outermost energy level, so it will be classified as a metal. A metal element has number of electrons in the outer level. آخر level عندي هنا في 1 or 2 or 3. I mean less than 4. So, metals are electric conductors. Why? Because the attraction force is weak between the electrons and protons. This force is weak force. Here we have a weak attraction force, which gives this electron the chance to be freely moving. So, metals are characterized by the presence of free electrons. Metals have free electrons in their outermost energy level. This is the electron in the outermost energy level. It is less attracted, or the attraction force between this electron and the nucleus is a weak attraction force, which gives it the chance to be a free electron so it can flow through the conductor or the material of the conductor. So metals are good conductors of electricity because they have free electrons in their outermost energy level. The attraction force between these electrons and the nucleus is very weak, and sometimes it disappears completely, giving the metal a chance to act as a good conductor of electricity. And now we come to our questions, or some of our questions in the session today. Number 1, give reason. The atom is electrically neutral. The atom, as a whole atom, is electrically neutral. Why? Because the number of positive protons, I mean positive charges, or the protons which carry positive charge, is equal to the number of negative electrons. Number 2, the nucleus is positively charged. Inside the nucleus, I'll say this is the nucleus of the atom. It contains two types of particles, protons and neutrons. Protons carry positive charge. Protons carry positive charge. Neutrons, as I mentioned before, are uncharged. So the strong charge which control the atom here is the charge of protons. So because it contains protons which are positively charged, and in neutral neutrons, I mean uncharged neutrons, so the effective charge in the nucleus of the atom is the charge of the positive protons. So the atom is electrically neutral. Here's just to compare between the electrons and nucleus. For their location, electrons revolve around the nucleus of the atom. They are located outside the nucleus. These are the electrons. They revolve around the nucleus. These are the electrons. They revolve around the nucleus of the atom. They look like the 8 planets in the solar system, which revolve around the sun. By the way, there is a great similarity between the solar system and the structure of the atom. And here we have the nucleus. For the nucleus, it contains positively charged protons and uncharged neutrons. We say uncharged or neutral, okay? Let's come to the copper atom. Copper is used in making the electric conductors or the electric wires. Copper is the most famous metal which is used or in making the copper wires or the electric conductors. Its atomic number, which is written here below the symbol, the atomic number is 29, and its mass number is like 63.5, approximated by 64. Okay, this is the electronic distribution, or the distribution of the electrons around the nucleus. We have levels K, L, M, and finally we have the outermost energy level, which is level N. This is level N. We usually say it's the outermost energy level. How many electrons in level N? Let's count the number of electrons in the outermost energy level. Level N here is considered as the outermost energy level. It has only one electron. This electron is very far from the nucleus, not very attracted to the nucleus. That's why we consider it as a free electron. And as a free electron, it can flow easily to make the copper one of the best conductors of electricity. So copper is one of the best conductors or best substances to make the electric wires. Why? Due to the presence of the free electrons. When I say this free or this electron is free, I mean that it is not attracted to the nucleus. The electron carries positive charge and the nucleus contains protons, which are positively charged. So between the positive charges of the electron, between the negative charge of electron and the positive charge of proton, there is an attraction force. But the attraction force here is not very strong. So the electron is going to be considered as a free electron. And as a free electron, it can be considered as good conductor of electricity. And from here we can conclude I think ان احنا نقدر نعمل deduction، نقدر نستنتج دلوقتي يعني ايه electric current. The electric current is the flow of electrons or the flow of the negatively charged electrons through a conductor. Okay, so this is a very important note. I can say this is a key word to the meaning of the electric current. When the attraction force is weak or vanished, when I say vanished, I mean it disappears completely. Electrons will leave the atom and become free. When the attraction force becomes very weak or vanished, vanished means disappear completely. For sure, this attraction force is between the electron in the last level, in the outermost energy level, and the nucleus. It makes the electrons or the electrons in the last level to become more free so they can flow easily through the conductor. So let's finally come to the meaning of the electric current. The electric current is the flow of electric charges or the flow of electrons. What makes these electrons flow? They flow because they are free. And they are free because they are less attracted, or there is weak attraction force between them and the protons in the nucleus. The weak attraction force makes the electron becomes more free. And as a more free electron, it can flow easily through the substance, which is a good conductor of electricity, like the copper and all the other metals. Okay? So the electric current is a flow of electric charges, or the flow of electrons through a conducting wire or a conducting material. My dear students, let me remind you of the simple electric circuit. To have a simple circuit, we should have an electric lamp or electric bulb, electric switch, and the source of electricity, which is the battery. Okay? This circuit is closed. And when I say the circuit is closed, most of you are confused. أغلبكم بيتلخبط في الجزء ده يا ولاد. When I say the circuit is closed, I mean the parts are connected to each other. The parts are connected to each other. A closed circuit is a circuit at which its parts are connected to each other. That's why the lamp lights. The lamp lights because the electric current can flow through the wire until it reaches the lamp, so the lamp lights. The role of the lamp here is to change the electric energy into light energy, as we know. So this is a simple electric circuit containing a source of electricity, which is a battery, and we consider it as a closed circuit because the parts are connected to each other. Okay, all these parts are connected to each other, so the electric current or the electric charges can flow until they reach the lamp, and the lamp can also change, or as we know, the lamp can change the electric energy into light energy. And this is as an indicator, an indicator for the presence of the electric current. This circuit is an open circuit. Why? Because the parts are not connected here. This is the electric switch or the electric key. The switch here is open switch. Okay, here's the source of electricity, which is a battery. The lamp doesn't light here. Why? Because the circuit is open. And for an open circuit, I usually say that the parts are not connected. Where? Here, this part is not, or the switch is not connected. The switch or the key here is not connected, making the circuit open. So an open circuit is a circuit at which the parts are not connected to each other. And if the circuit is open, the electric current cannot flow, and as a result, the lamp doesn't light. Okay? So this is a difference between an open circuit. This circuit is open. The parts are not connected to each other. On the right side or in the other side, we have a closed circuit. When I say closed circuit, I mean the parts of the circuit are connected to each other. And here's the difference between closed circuit and open circuit. My dear students, who can tell me the circuit is open or closed? I can hear your answers. You say it's open because the switch here is not connected. So an open circuit is a circuit like this one. The circuit is open circuit. Why? Because the parts are not connected to each other. And for the circuit to be closed, the parts should be connected to each other. It looks like a closed continuous path of the electric current. And for the electric current to flow, all the parts should be connected. The circuit should be closed circuit. Okay? My dear students, here are some parts of the electric circuit, some components of the circuit and their symbols. We have an electric lamp, and this is its symbol. The switch or the key, the electric switch or the electric key is just used to control opening and closing the circuit. And here we have its symbol. Here's the circuit, the switch or the key is open. On the other side, the key is closed. And this is the symbol of the closed key. When I say closed key, I mean it is connected to each other and to the other parts. And here the wire, the symbol of the wire in the circuits, battery, and the battery is very important. Why? Because the symbol of the battery is represented by two lines. As you see here, the battery is represented by two lines. One of them is a short line representing the negative pole of the battery. On the other side, we have a long or a tall line. The tall line represents the positive pole of the battery. So, the battery or the electric source in the circuit is represented by two lines. One of them is tall line, another one is short line. The short one represents the negative pole. The long one or the tall one represents the positive pole. And here we have another electric source containing more than one battery. So one of the most important notes here, the two parallel lines in the electric circuit represent the battery or the dry cell. By the way, we can say the battery or the dry cell. The tall or the tallest line is for the positive pole. The smallest line or the shortest line is for the negative pole of the battery. So let's discuss the idea of the ability of the free electrons to flow through a conductor. And when can I say that the electron is free? Depending on this idea or upon this idea, electric conducting wires or electric connecting wires, or for the wire to be considered as good conductor of electricity, they are made of metals. Because metals have weak attraction force between the protons and the electrons. So, by connecting these wires with an electric source, what will happen? There will be a force called the electromotive force. The electromotive force is just like pushing force. This force is generated and the electrons are pumped or pushed to move in the wires or in the conductors, creating the electric current. So the free electrons of metals can flow through the conductor. When can they flow through the conductor? When they are connected, when we connect them to an electric source. What happens when we connect the wire, which is made of metal, to an electric source? When the wires are connected to an electric source, there will be an electromotive force. This force will push or will pump the electrons to move through the conductor, and this is what we call as the electric current. My dear students, as you see, this is an electric wire, and from this wire we can take what we say or what we call حاجة بسميها cross section. This is a cross section. You can cut it like this. What are the properties of the electric current that we are going to study in our lesson? We study the first property, which is the current intensity, the potential difference, and the electric resistance. Let's get started. When I say this current is an intense current, intense I mean very strong current. These are the free electrons which can flow through the conductor when we connect them to an electric source like the battery here. When we connect the wire, which is made of metal, to the battery or to any other electric source, the free electrons, as you see, will flow in the conductor, and this is what we call as the electric current. The current intensity is how many electric charges flowing in the wire. The quantity of electricity, and the quantity of electricity is measured in coulomb, or the electric charges, or the number or the quantity of electric charges which can flow through a cross section. I'll say this is an electric wire or electric conductor. If we cut it like this is called a cross section of the wire. How many electric charges, how many electrons, or the quantity of electric charges that can flow through it in 1 second is called the electric current intensity, and we usually give it letter I. Letter I comes from the first letter in the word intensity. Here, this letter. From here, we give it letter I. So the current intensity, which is a quantity of electric charges that can flow, I'll say this is a wire. If I cut it like this is a cross section of the wire. Cross section of the wire. How many electric charges flow in this cross section in 1 second? This is what we call as the electric current intensity. So it is a quantity of electricity in coulomb flowing through a cross section of wire in wire or conductor. Both are right. Okay, this is the mathematical relation that we depend on to measure the electric current intensity. I equals Q over T. Q is the quantity of charges, T is the time in seconds. So the current intensity is equals Q over T. Q is the quantity of charges, T is the time measured in seconds. And here's the magic triangle that we usually use to measure. From here, I mean from this relation, I can determine the current intensity, the quantity of charges, and even the time measured in seconds. So the current intensity, which takes letter I, equals Q. Q is the quantity or the number of charges over time, which is measured in seconds, okay? What is the measuring unit of I? I mean current intensity. Current intensity is measured in ampere. The measuring unit of the I mean the current intensity, is ampere. We usually say it's ampere, okay? Back to the mathematical relation, we say that I, which is the intensity of the electric current, equals Q over T. Q is the number of charges or the quantity of charges time takes letter T. The quantity of electric charges, I mean Q, is measured in coulomb, and the time is measured in second, and the I mean intensity, is measured in ampere. So 1 ampere equals 1 coulomb per 1 second, and this is the first relation here. And then we can define the ampere as the electric current intensity. By the way, I just remind you that I equals Q over T. So the ampere, I mean the measuring unit of current intensity, it is the electric current intensity passing through a circuit when a quantity of electric charges of 1 coulomb passes through a cross-section of time in 1 second. A cross-section of wire or conductor in 1 second. What is meant by the current intensity or the electric current intensity passing through a conductor is 1.5 ampere. It means that the quantity of electric charges that pass through the conductor in 1 second is 1.5 coulomb. Now, my dear students, let's answer this question. Let's read the question. Calculate the current intensity, I mean I, passing through a cross-section due to the flow of a quantity of charges of 5,400 in 5 minutes. So I equals Q over T. The value of, the value of the current intensity, as I mentioned, equals Q over T. Q represents the quantity of electric charges. How many charges here? 5,400, and the time is given as 5 minutes, so it will be 5,400 over, it's, as I said, it's 5,400 over the time is given in minutes. You have to change it into seconds, so it will be 5,400 over 5 multiply or times 60. So the current intensity will be 18 ampere. The measuring unit of the current intensity is ampere. Another question, my dear students. Let's come to the last question in our session today. If the electric current intensity, which takes letter I, is 6 ampere, passes through 15 seconds, find the quantity of electric charges which pass or that passes through a cross-section of the conductor. First of all, we should write the rule that we apply here. I equals Q over T, and the required value here is a Q, I mean the quantity of the charges. So Q equals, this is from the magic triangle, I times T. So Q, I mean the quantity of charges, equals 6 multiply 15. 6 multiplied or times 15. 6 times